How's it going? Good morning, everybody.
You're just going to wait for a couple more people to join us. Thanks for being early. So
Yeah.
now we'll be entertained by some stand-up provided by
Yeah,
Tobias.
I was actually having a conversation about meetings going late on Zoom. I feel like it's harder to end a meeting on time during Zoom. There's not a natural get up and walk out of the room. So we appreciate you guys being prompt and on time is the takeaway there.
All right. Joel, do you want to provide some info on how to ask questions, how we're going to handle questions?
If you submit questions into the Zoom webinar instance, they'll start populating on my end, and I will sort them and we will answer them in the order as received at the end of the webinar, which will be in around 30 minutes. We're at 35 so far.
All right. So, shall we maybe kick off a little?
I think we can do it. We can start with intros and let people trickle in.
Okay, well, welcome. We are broadcasting here from our headquarters in Palo Alto. Really excited to have everybody here. We had a really high RSVP rate, so I'm sure people will continue to kind of pull in. And wanted to take the opportunity to talk through essentially now that we're here in fall at the end of main production season for many of the consumer electronics companies that we work with, to essentially leverage our data set and help others identify what are kind of the top issues that are coming up in production. And so that's what we're here to talk about today. So my name's Anna. I am CEO and founder of Instrumental. I'm a mechanical engineer by training. I was at Apple for 6 years, helped work on a handful of iPods, as well as led product design for the first generation Apple Watch. We've been in business as a company for about 5 years. And this webinar, I'm lucky to be joined by Tobias. Do you want to introduce yourself?
Yeah, hello everybody. Tobias, also mechanical engineering background, 6 years at Apple as well, sounds very similar. Doing product design, iPhone, Apple Watch, primarily touchscreens and health sensors. And I've been at Instrumental about 1.5 years now. And I remember the first conversations I had with Sam and Anna, and kind of the two revelations that I had. One was that the struggles of the PD life that I've been experiencing year after year, they weren't actually unique to Apple. And it was actually this entire industry that was having these same struggles. And maybe I was just in my own little bubble, but I hadn't realized the full scope of that. And the second was that this team here was actually building tools to help out with some of these issues. I hadn't even realized that that was an option besides just brute forcing my way through. So those two things made me really excited to join the team here. Yeah,
and since then, I think you've helped quite a few customers get products over the line in both development and ramp and production. So we're going to dive into the next slide here and talk a little bit about what we're going to chat about in this session. So the structure of the session we thought is we might do about 30 minutes of actual content, followed by as many questions as there are. So you can put those questions right in I think there's a Q&A button approximately here. And so today we're going to talk about a little bit of the demographics of the data, where the data comes from, so people have an understanding of how to kind of assess the information that we're sharing. We're going to unveil the 2020 edition of the top 10 production defects. So these are defects that are actually would have shipped if they were not caught by Instrumental. We're going to do some meta-analysis of that data because there's some changes between 2019 and 2020. And as we look ahead to 2021, which is certainly an unprecedented kind of challenge for the industry, we're going to talk about what what we're hearing from our customers and our friends who are struggling with these challenges, and kind of what maybe some sneak peeks on some new stuff that's coming out that we're going to be announcing in the next month or so from Instrumental. So to give you a little bit of an idea of what the demographics are, I think you're literally wearing the same shirt.
No, slightly different. It's the engineering outfit, the PD outfit.
So for core data demographics, so we've analyzed over 3 million ramp and production units to make this data set. Not all of the data that we collect is data that we're able to use in this way. This is aggregated and anonymized across many customers' data that they've given us permission to use it for this type of analysis. We have over 100,000 defects detected that have actually been included in this. So that gives you a sense of the scale of how many, when we say that there's actually a percentage of failure rate, it's coming out of this 100,000 defects here. This spans over 10 customers, primarily in consumer and enterprise electronics companies. And these are all products that are assembled in the world's premier factories: Pegatron, Flex, Fox. These are world-class operations. Certainly there's some that are there's others included that we can't talk about as well, where many customers also sometimes have their own manufacturing and their own factories. So we're gonna kick it off by starting right in here with the top 5. So Tobias, you wanna kick us off?
Yeah, let's do it. Number 1, no surprise here, glue issues. So glue, I mean, a lot of you guys know it's a notoriously hard process to control, even with an automated dispense. So this bucket, this includes structural glues, environmental seals, potting, as well as conformal coating and some underfill on some PCBs. So it's a pretty broad category, but again, all of these defects, these could be critical to either securing parts in place or the environmental seal of the product.
Yeah, absolutely, and they're hard to detect.
They are hard to inspect for, hard to keep consistency over time. And so it's really, yeah, it's not a surprise that we're seeing this at the top of the list here.
Awesome. Let's see number 2. So number 2 is missing foams, which might seem like a small thing, but I think unfortunately many of these foams are often part of the conductive grounding loop. So they're conductive style foams, not necessarily. The other common place for uses of foams would be on the back of board-to-board connectors to keep those connectors down. So both are quite critical. These connectors popping off is a really bad experience for your customers. And then for these conductive foams, it's really difficult to actually identify in a functional test, if your grounding loop is not great, because you might get intermittent test passes or failures, and you might get dropped calls if you're working on phones, or you might have unreliable intermittent antenna performance otherwise. So that's number 2.
And coming in at number 3, tapes and labels. So this one, primarily a manual process, and any type of manual process is highly prone to either operator misplacement, other types of operator errors. This bucket, so this includes adhesives as well as some conductive tapes, again, that are pretty hard
tapes,
to, yeah, copper
Kaptons,
tapes.
stuff that wrinkles, as shown here.
Yep, some cosmetic labels too. So again, another pretty broad category that's pretty difficult to check for besides just a manual check or some type of more advanced visual check like this.
Yeah, I think one of the cases of one of the customers, they were actually using a Kapton to create an isolation layer between electric components and a very low sealing of a shield can. And so like missing a tape like that is a really big problem. You might get shorts. So that's kind of that one. Okay, what's number 4? So number 4 is soldering. Ideally, well, not ideally, but generally this is hand soldering. This remains at the top of kind of the concerns that many of our customers have around hand solder joints, particularly joints that don't, completely fill in the way you expect or have cold solder. Some of that stuff is visible. Some of it you kind of have to do a combination of inspection plus test for. But anytime you have a human that's doing a process like that, like soldering or gluing, glue pumping, you're going to get, at least the kind of wet processes, you're going to get challenges. And so soldering kind of rose to the top. It still remains a high issue.
And number 5, wire routing. Yeah, this is another tricky one. This includes both just wires being misplaced, as well as you know, the little coax cables with the grounding clips along them, missing those clips. And again, this is another one that's pretty tricky to actually catch with a functional test. If you're missing one clip, it could affect RF performance, but you're probably not going to catch that at the end of the line. So it can affect the actual RF performance. A lot of times, if the wire's in the wrong spot, something's probably not going to fit together right.
Yeah.
As well.
That's like a major problem for the customers we have that work on much larger items. We have these large wire harnesses, and getting those in the right spot is one of the challenges they come to us with.
Yeah, and another one that's kind of hard to detect if the wire's off just a few millimeters. It might not be obvious to a manual inspection that it's in the wrong spot.
Yep. All right. So that's number 5. And here are the rates of these defects, and we'll be sending out a PDF afterwards, so you don't have to screenshot this slide. But I think the core takeaway from these rates is probably higher than you thought it was. And keep in mind, these are units that are these are defects and units that would have likely shipped, and so are shipping. Is kind of the way of thinking about it, because not every company is an instrumental customer, so not every company is able to catch this stuff. But again, this was a survey across 3 million units, 100,000 defects. Like these are definitely happening in your products at similar or maybe slightly different rates depending on impact. How many glue locations you have, or how many tapes and labels you have, need to be accounted for as well. So these are on an individual basis. What's the kind of probability that there's a defect? And glue issues having almost a 1% hit rate. This is something that's not showing up on your Pareto, which is actually kind of the point of our next slide, which is that most of these, actually all of these, cannot be reliably caught with functional tests. You might be able to get lucky and catch some of them or sometimes, but not reliably. And so this makes a big challenge that, like, you just add up what's on this slide here, and we're talking about 2% or more, essentially dark yield, we call. That's items that should fail in the factory, but often ship in as escapes into the field and then show up either as returns or total warranty returns. All right, let's go to the next one. So what do we got here for number 6? Functional part missing. You want to grab that one, Tobias?
Yeah, definitely. This is one where you would think that functional parts missing, easy to catch at the end of the line. The thing that we're seeing with a lot of customers is the tests are way down the line, and actually catching these where they are caused early on in the process is hugely beneficial. So this could be functional parts on the PCB that were just missed earlier on, as well as things that get knocked off during some of the manual assembly steps.
Yeah, so this one you will catch in a test, but if you catch it downstream, it'll be expensive. Yeah. And so that's where you could get rework, and different products have different costs of rework. So if you have a high cost of rework product, this might be a place that you'd be getting those failures from. Okay, what's next? Okay, misaligned parts. So this one's pretty obvious. Some parts, in order to work the way you want them to, need to be lined up properly, particularly as more and more products come out with different types of sensors that are pretty sensitive. We're trying to increase complexity of these products. It's really important that parts are aligned properly. And those misalignments can lead to like funky errors that can actually be really difficult to figure out. Certainly we've had customers who were able to actually make a correlation to some kind of, how much space there was between a flex and a housing being the result or being the root cause of a particular failure mode they're trying to find. So it can be really, really challenging to find. What's the next one?
Oh, yeah, connectors. I've got some personal experience with this in the past. This is another very difficult to catch one. This can be partially unplugged connectors or completely unplugged.
Yeah, especially like these zero insertion force ZIF connectors. Those are rough.
Yeah, the ZIF is probably the worst culprit here. Of course, it could easily pass functional tests. Very difficult to actually see the misalignment. I'm actually seeing more and more people intentionally adding visual inspection marks, the little white line on the flex, because it is so difficult to tell just a slight rotation of that connector. So this is it's not in the top 5, but it's a very critical one to miss.
Yeah, because this if you have something like this, like a ZIF that's not fully plugged in, you put it in a box, you ship it to a customer,
It's gonna.
it's like DOA by the time they get it. So
Yeah.
even if it was okay on your in your functional test. Okay, next one. Protective liners. So this one's tricky for me because we as engineers, we design these liners, we know they get thrown out, but they're trying to protect kind of usually optical surfaces like cameras, things that you don't want fingerprints on, things you don't want dust inside of. Adhesives. You want to make sure those release liners are actually there for the duration that they were designed for before they get peeled off. And so a lot of folks, for years we've been making these liners bright colors so you can very easily see that it's there or if it's missing. But that this takes additional thought. Like many liners coming from suppliers will be clear and can be hard to see. And sometimes they also get left inside the product. So it can be a challenge, but that's kind of the issue here is that without these liners, you can have dust ingress to sensitive optical or other structures that you're relying on having clean surfaces for. All right, and what's number 10?
All right.
Perfect.
Last,
there you go.
Certainly not least.
Like peanut butter and jelly, those two there.
Yeah, exactly. I wonder if some of these are overlap where they took it off early so they had contamination.
Yeah.
So this bucket, critical parts like cameras, sensors, it's pretty easy to get contamination.
Yeah.
Especially, bringing up new lines, bringing up new factories. This is like a key thing that engineers spend thousands of hours trying to get rid of. And again, pretty hard to inspect for. So normally a manual inspection is the best way to do it. And so being able to actually reliably catch it is pretty valuable.
Yeah, absolutely. Okay, so here's our full roll-up of the top 10 defects and their relative incidence rates. In terms of incidence rates, this is per item. So if you, and that's actually kind of leads into our next kind of honorable mention, which Tobias is going to present.
Yeah. So let's talk about screws. Some of you guys might be thinking, missing screws. Was that not on the list anywhere? So the incidence rate of a single missing screw didn't make the top 10 list. So that's this 0.04%. But what we need to remember is most products, like this example here, have a large quantity, like 10, 11, 12 screws, and each one of those screws has the same probability of being missing. So when you look at a per unit, it's actually much higher, almost up at 0.5% chance that
depending
it could be
on how many
screw.
screws you have.
Yeah, it could be
more.
even higher than that, like really complex electronics. So once we take that into account, this actually would push it, I think, about number 5 or so.
Yeah, it's definitely up there in the top list. And I think this one's tricky because it's highly dependent on the product. And the squiggly equals, for those who are eagle eyes in the audience, this is, you don't exactly multiply these together. We can share the math later if that's important, but for this particular example, it ends up being the same order as what we're showing there. So yeah, so screws, very important. So let's do a little bit of analysis. So one of the kind of core pieces of our analysis is that we really saw a surge in glue defects this year. Like it went from being ranked 5 last year to rank 1 of this year. And I think that just like is for several reasons. One, I think as products get smaller, it's harder and harder to put things like screws, which were actually on the top 10 in their own right last year. It's hard to fit screws in as products get smaller. And we're also seeing that customers, I think, had a harder time controlling glue this year than last year. And that may be because of a lot of remote manufacturing this year. Teams aren't as close and aren't able to work as closely with their vendors. And so we actually saw that defect rate increase by almost 3x in the last year comparing the data sets. Now, certainly there's some like measurement bias, like we're not looking at exactly the same products in 2019 as in 2020, but we saw a trend both to using more glue and to higher defect rates. So essentially, the takeaway for glue is it's really difficult to control glue dispense processes because they're so impacted by many other variables. And so you really want to either avoid glue if you can in the design, or you want to have an ongoing quality control plan for how you're going to make sure that you not only can find these defects when they happen. Keep in mind, these glue defects are not all defects that an operator would have pulled out. Many of these would have shipped. And so finding them in advance when it's, when you can clean it off, when it's pre-cure, when you haven't like put the parts permanently together, would be really helpful here.
All right, another trend, if you'll notice in the top 5, we have glue, tapes, and screws. These are all attachment methods. And so the reality is it's tough to attach things permanently and to get your environmental seal. So there's a lot of debate about, should you go with glue? Should you go with screws? Honestly, I'm a little surprised the glue is not higher. It's a little bit higher, but I was actually expecting the glue to be a much higher defect rate just because it's so difficult to control. One thing to keep in mind though is these glue defects, a lot of times this will be one glue process, which might be sealing your entire device,
Yes.
making the seal. And again, the screws, like we talked about before, there's lots of independent screws within a product. So you have to take that into account when considering like the likelihood of something going wrong.
Yeah.
Interesting. Yeah, kind of the takeaway here is I'm not going to tell you if you should use glues or screws.
That's highly controversial.
It's too controversial.
But whichever
That's for
one.
prime time.
Yeah, exactly. Stay tuned for whichever one you do pick. Besides just validating that the baseline design works, you want to make sure you have an ongoing quality audit plan in place. This is similar to what Anna was mentioning, to make sure that this process doesn't drift over time. And one of the, on the adhesive side, I remember one of the clever things that we did back on, I think it was the Apple Watch. It's really tough to see the adhesive once you put the cover glass on, because it's all covered up. And how do you know if it's actually adhered properly? So one of the things we did was we actually fabricated completely clear cover glasses, so no black mask. Same thing on the back, completely clear. And then on a periodic basis, every day, every shift. Yeah, exactly. And then just adhere down those clear ones. And then that actually allows you to see the full adhesion surface to see if it's wetted.
Yeah, that and pressure paper in all of your presses.
Yeah, exactly.
So if you haven't experienced the wonders of pressure paper, this is a type of film that has 2 parts, and it will actually tell you if you get like an even press across your pneumatic press if you're pushing 2 parts together.
Yeah.
Critical for that too.
Exactly. And now that we mentioned it, that would actually be really interesting to document the pictures of that.
Of the pressure paper.
In instrumental, so you'd have that historical record.
Yeah. All right. What's next? Okay, so last kind of piece of analysis here, just like there's some newcomers to the list. And so wanted to kind of talk through those. So soldering, we actually had a pretty limited sample size in 2019. So it's not that soldering is like new and like there's something going on in the industry that like soldering is worse than it was before. It's just that it didn't make the cut last year because we didn't feel like we had enough data to support its candidacy on the top 10 list, but this year we do. And so that's what's kind of leading to that one being in the top 5. And then misaligned parts is actually new to the list. And specifically, I think why is just the devices are just getting smaller and more complex. And so as you do that, it gets harder and harder to get parts just so. The tolerances are going down and down for placement. And so that's likely why we're ending up with more sensitive assemblies, more sensitive designs that our customers are working on, leading to more misaligned parts. And then contamination, generally, I think the reason that one's now made the list is just because as there's more and more sensors in the various different types of devices, like even devices that in the past wouldn't have any sensors at all, getting various types of sensors, particularly optical sensors. Interestingly, instrumental is used on a lot of products that have cameras, even though we ourselves are a camera-related product. And so I think is one. And then we also mentioned that glue, just the prevalence of glue had gone way up. And so contamination is something that actually happens also when you're doing a glue bond as well, because you're looking for particles or fibers, or we actually found a feather in one of our customers, like a down feather had like fallen into the glue. No bugs this year at least, but that's likely why that one has made the list. So if we look ahead to kind of 2021, teams are actually starting NPIs now. So that's why we thought this would be a great time to share this data. There's opportunity for you to maybe take a look at this and rethink your assembly and your plan, given it's unclear how much travel, at least for US-based electronics brands, are going to be able to do this year to their factory partners in Greater Asia, maybe in other parts of the US or in Europe. And so we're kind of seeing that this is, we know this time going into this cycle that there's going to be a portion of it that's remote, if not the whole thing that's remote. We didn't know that last time. And so everybody just tried to make lemonade with what they, you know, kind of what they were given. But this time there's actually opportunity to do something. And so we're really seeing a desire and like an insatiable thirst, at least in talking to prospects or customers around real-time data access, to be able to have oversight to what's going on, knowing that their teams are not going to be able to work night shift here in the US for sustained periods of time for the next program cycle, and really seeing that as table stakes for 2021 in terms of new product introductions, developments. We're also seeing a lot of interest around using multimodal data sets. So this means data sets from multiple places, kind of putting those together to actually drive rapid correlations, which is enabling teams to work a little bit more efficiently. So we're going to talk about some of those trends next here. So as kind of a little bit of an introduction to Instrumental and kind of how our product is playing into this concept of insatiable thirst for data and getting that data, really what we are doing is taking in a variety of different types of data, product data from your line, whether that's a visual history data from images, we can pull in functional test results or measurements from your AOI systems. You might have other external data streams. All of that data comes into one platform, and then inside that platform, there's opportunities for different stakeholders on the team to actually do work with that data. Traditionally, companies might expend efforts to try to improve the operator side, put in an AOI, try to replace the operator's need for understanding if there's an issue or not, or they might invest up here for the VP of operations or leadership on the business intelligence tools dashboarding. But we don't see a lot of investment by companies kind of in the middle for engineers and quality engineering, looking, actually discovering and fixing the defects. And we see that there's a significant opportunity when you can actually pull all this data in and everybody's working from the same data set. They're not siloed anymore. So that's what Instrumental does. And kind of as we look at trends, so maybe next slide, as we look at trends, real-time oversight being one critical one that we're hearing a lot of desire for, and really it's a must. And the way that you get real-time data is you got to go to the cloud. Luckily, the cloud's been around for a decade, but this is really the best tool. This enables you to actually have potentially factories in multiple locations that you don't have people at, and all of that data is coming in one format, in one place, and all of those different stakeholders on the team can actually work on the data to do their work. And so we're finding across our customer base and the folks that we talk to and our friends, getting this real-time access to performance test data is absolutely table stakes. This is something that companies have, implemented S3 buckets or getting log files for years. They've built kind of janky systems to do this, to try to make that work for them. But putting data in a folder and not doing anything with it is kind of a missed opportunity. So we're seeing a lot more interest in being able to leverage that real-time performance test station data. Certainly images help. We've talked to prospects who are trying to take video or do FaceTime calls for hours, trying to understand like what's going on the line. And so getting that kind of insight as to what's happening, whether you're there or not, super critical. In terms of the multimodal correlations, we're actually going to provide a little bit of a sneak peek here for some new stuff that's coming out that we haven't announced yet. So you guys are lucky ducks. And so what is a multimodal correlation? It's taking data from two or more places and actually trying to find a relationship between them that can lead you to a potential root cause and a potential corrective action. And so what Instrumental is now doing is we're actually pulling in functional test station data directly into the application. So on a particular unit, you can actually see what it failed for. You can filter units that failed and then actually do your failure analysis in situ right next to the images that could actually have information that you need to solve those problems. One customer recently used correlations to actually identify an issue that they've been struggling with in production for quite some time, and they only had about 250 units worth of data, and they were able to actually solve that because they finally had the data kind of next to each other to start to make these correlations. And I think this is really exciting for Instrumental because there's so much more that we could do here, and this is kind of just the first little pulling back the first little corner on what's going to be available. So that's that one. And our second and last sneak peek is really around getting luck and heroism out of the development process. And so we're introducing and going to be introducing really soon something called Instrumental Discover, which leverages AI to actually find defects for you, whether you don't need to know what you're looking for or where you're looking. We have AI that will look and will help you find that. And we're actually, we've been running this in a closed beta for the last quarter or so, so throughout the kind of production season, and we're now ramped up to discovering about 100 new defect types per week across our customer base. And so these are not just 100 defects. This is types, completely new defect types that our customers were not aware of, that we're now able to discover for them, and then they can use that information to take a step forward, figure out how to fix those issues, make sure those issues don't come back. So this is really exciting for us. Really, the reason this is important is because we're talking about optimization, and what we really want to do is we want to pull data from across the supply chain, understand the inputs to your process and the outputs from your process. And if we have inputs and outputs, then we can actually help your team optimize the process overall. So don't just find issues here at the end of your line, find issues where they're happening, including if they're upstream or in other facilities than your main final assembly and testing line. So that's everything that we prepared, and we'll see if there's any questions.
We have 3 questions.
All right.
One is, what is the image capture rate at the camera?
The image capture rate. So I'm guessing the question is about how many units you could actually flow through. And we've got a couple different options. Our standard manual stations, it's about 8 seconds per unit. Most of that is loading and unloading of the unit. And then we also have a production over conveyor version, which gets down closer to 5 or 6 seconds for higher volume mass production.
Yeah.
So it's in all the situations where it's implemented, it's never the slowest. It's never gating the line. So we work with our customers to make sure that it meets the requirements.
Yeah. We can also look at special purpose machines. If you have automation where you're taking images, like our inference time is much shorter than that 5 seconds. It's just usually we have to manipulate a unit through, and we're including that.
Yeah, exactly.
In that analysis.
Second question, where is the speed bottleneck for resolving or catching failures?
The speed bottleneck.
Assuming we're talking about the actual processing of the image.
We can answer it in a couple different ways. We can answer the processing of the image, and maybe we'll talk more broadly about the process as well. So why don't you talk about the image details? Yeah.
So similar to the last question about we have 8 seconds, let's say, about 2 seconds of that is the actual processing. And that's actually done locally for that live inference, the live pass fail. So there's some local processing that's done with whatever tests you have set up running that AI. So for the live results, that would be the bottleneck, is actually the local processing.
In terms of more broadly, zooming out, if you think about where is the bottleneck in essentially finding issues in general for a new product, ultimately it's kind of, there's kind of 2 places where we see bottlenecks. One is just finding the issues in the first place. And, I used to, and I know Tobias did as well, we used to fly to China, stand on the line for 8 to 10 hours a day, trying to be in the right place at the right time, apply luck to find those issues. And luck is a silly word to include in manufacturing. It's just like, it does not compute for me. And so that's why we built Discover, was to be able to try to get luck out of manufacturing, try to get rid of that bottleneck to actually discover the issues. Because when you have an issues list, like, engineers can ferociously work through that list and solve those problems if they know what they are, and if they have an idea of how big of a problem it is. So I would say that's probably the main bottleneck. The other bottleneck we see is just getting the data that you need to actually solve a problem. So you might get information from the factory that, like, oh, we had some microphone failures, but they didn't send you the data that goes with those failures. They just let you know that they have failures. And then there's like a multi-day process to try to get that data to be able to kind of move forward with the analysis. So those are kind of the two bottlenecks that we see in the development process.
And the one thing that I've seen more recently, so when you're on site, back when we could travel to the factory, a lot of times the bottleneck was finding the issues to go tackle them together as a factory and, PD engineering team. Now, a lot of times I've seen the bottleneck is actually the solving of the issues asynchronously because of the different time zones.
Yeah.
So there's a lot more back and forth. The factory spends one day doing some work, but then they might be gated by input from the US engineering team. So it's this asynchronous problem solving that the teams are trying to figure out how to expedite and how to actually resolve problems faster.
I'm remembering back when I was like doing this work at Apple, and I'd fly into the factory, and then you'd leave the factory, and you'd feel like you knew what was going on for like 2 days after you got back home, and then you were like useless. You had like no idea what was going on anymore. Yeah. And so it was like really only useful to, the folks who are on the ground. There was always a thing of like, you trust the call on the ground, because the person on the ground has much more information about what's going on and why they should make that call. And I was just reflecting on thinking about what you were saying around, this is so hard to not be able to be there. And so you're essentially just as useless. So, really trying to pull in data can be really important for that.
All right, third question. How many units per second does the platform process if the capture speed is unlimited?
Oh, interesting. So images, I think referring to if images were just streaming into the cloud without actually being limited by operators putting them in and putting them out. In the background, I'm not sure what.
Two factors. There's like the speed of the camera itself, and then there's the speed of the bandwidth connection of like what you could get out, right? If we're thinking about it in a practical sense.
Yeah, practical sense. And then I wonder if the question is more hypothetically, if we were piping a lot of images into the cloud, which is a little less restricted. Yeah. Because there we're able to like leverage all this different parallel processing.
Yeah.
Do
you know what the rate on the camera is to capture images?
The actual image capture, it's milliseconds to capture, and then it's about a second just getting the image to the computer. Yeah. And practically speaking, that's what's going to be limiting us at all time. But if hypothetically we could get more images like from multiple spots on the line, if we could get all those images into our cloud, that's one of the huge advantages of having all of this done in the cloud is it can scale out hypothetically as large as we want in parallel.
Yeah, I think for clarity for those who are on the webinar, we do real-time processing at the edge for inference on pass-fail for tests that have been set up. But those tests are kind of the result of a whole discover, solve, and monitor kind of loop that an engineer does with the cloud platform. And all of our training of those algorithms are actually done in the cloud. And that's because training takes a lot of resources, and so we can leverage the massively scalable resources of the cloud to do that. We're finding, particularly when we first started this business, like maybe about 5 years ago, we found that in rural parts of China, the network bandwidth was pretty limited, and we were still able to operate at production speeds as little as 8 megabit per second speeds. So you don't need if the question is really around like kind of the bandwidth piece, you don't need a ton of bandwidth to be able to have this on the line. It can be with less bandwidth. Certainly the factories that have higher speed internet connections, it's better because our customers can actually see see a live stream of what's coming off the line, and actually see those defects as they're happening, or units as they're happening, and be able to see that from inside the app without a significant delay, maybe a minute or so before it shows up for them.
All right, final question. Of your top 10 list, can you provide a rough estimate of the percentage of root cause issues created by 1, automation, and 2, manual processes?
Ooh.
Well, the glue is mostly automated.
Yeah. Glue, let's see.
You want to bring up our top 10 list for us, and we'll pontificate?
Roughly
There we
breaking
go.
down. There's a lot of manual, that's for sure.
Yeah.
Probably automation, probably mostly manual.
Soldering is probably 50-50.
Split.
We see a lot of customers start with manual soldering and then really kind of drive over to robotic soldering, but the robotic soldering is not perfect, and they often don't get consistent, like if you're trying to use the solder as a mechanical joint as well, we're not seeing like fairly consistent. Wire routing is manual.
Manual, that's probably.
This is manual probably, right?
Yeah, that's probably manual because something had affected.
These are manual.
Manual.
Yeah, so glue and soldering are really like the main ones that come from automated lines. One of the challenges so instrumental, we typically will drop in on either fully manual assembly or hybrid assembly, where there's parts that are done by people and parts that are done by machines. We don't currently exist on any fully automated lines. One of the challenges of fully automated lines is you can make a lot of parts really fast that are not good. So there's certainly lots of opportunity there you want to make sure that you've got like good quality control procedures in place. But yeah, a lot of these are really driven by manual assembly steps. We've had customers in the past, like not part of this data, customers in the past who've tried to do the connector ones automated, and really ended up mashing the connectors. Is really difficult. That like particularly the very small pitch board-to-board connectors, like there's not a lot of lead in. There's kind of like a soft touch required that the human hand has that an auto align and like mashing robot just can't get. So we've seen, not in this data set, but we've seen customers really struggle with that kind of damage that happens for doing some of these things. But yeah, great question.
Yeah.
And that
wraps us up. Okay, well, thank you
awesome.
everybody for attending, and we hope to hear from you if you're interested in receiving a PDF of the top 10 defects or further information about anything that we presented today. And we hope you have a great rest of your Tuesday.